Ahmed, 37-MET from the Brainy team. In the digital system design course, we were asked to use Verilog and the FPGA provided to make a digital system. The problem of elder people living alone without someone to remind them of their medication time triggered us to find a solution to help them. So we modified the existing medical dispenser so it acts like an alarm to help them remember their medication time every 24 hours. Throughout this video, we'll show you how we approached this problem and how we found a solution for it.
Hi, my name is Ahmed, a 37-MET student from the team Brainy. I was responsible for connecting the proximity sensor. The proximity sensor which works when something approaches it. It's an active low sensor, which means its output 0 which is working and one otherwise. It has 3 wires, 2 wires for its supply, the VCC and the ground, and 1 for its output. I first tested it using a LED. I connected the VCC and the ground, its supply, with a voltage source, and the output to the LED. When it works, it outputs the LED lights. If it is not, it doesn't light.
Hi, my name is Dina Hisham, a 37-MET from the team of Brainy. In this project, we used 2 servo motors in which I was responsible for implementing. The servo motor has 3 wires, 2 wires that works as a power supply, and the 3rd wire was used as an input signal. I used the data sheet of the servo motor to find the frequency in which I used to supply the frequency for the pulse width modulation, also known as PWM. The pulse width modulation is used to specify the direction and the speed of the servo motor. In this project, since we used 2 servo motors, we used them in different directions due to the fact that we placed them in different positions on the medical dispenser.
Hello, I am Dr.Mohamed, 37- from the team Brainy. I'm the one who was responsible for connecting the smoke sensor to our project, which whenever it detects gas in our project smoke, presented as smoke, it gives an output to keep the pills safe from anyone who is smoking cigarettes around it. The smoke sensor consists of 3 wires, yellow, red and black, where the black connects to the ground, the red to the VCC and the yellow to the output of the FPGA. I used the pin planner of the FPGA to view the word gas on it whenever it detects a smoke around the smoke sensor. The word gas, each letter on a specific segment of the FPGA, knowing that the sensor is active low, so the output has to be considered that it is active low.
I'm the one who was responsible for the electrical connections of the whole circuit to the whole project, such as LEDs, sensors and buzzer. The whole concern was to integrate the whole circuit to work as a unit. I used 2 breadboards in addition to the FPGA kit, so I focused on having one common ground for the whole circuit. I supplied the voltage from the FPGA kit, which was a 5-volt pin, to the LEDs and the buzzer, and it supplies voltage when the proximity sensor detects a human approaching the dispenser, in addition to the external voltage source for the 2 servo motors.
Each member of my team finished their part. I was responsible for implementing the top-level module which connects the whole circuit together. At first I instantiated a clock to count the 24 hours. Whenever it counts the 24 hours, it supplies the circuit with voltage to make the buzzer and the LEDs work. At this time, if you approach the proximity sensor, it will detect you and it will open the box. It will cut the voltage of the breadboard, and it will reset the counter to 0 again. This smoke sensor was made for safety precautions, which will detect any smoke or hazardous gas and display the word gas on these segments. At any time you can approach the proximity sensor to make the box open and refill the slots in it, and you can reset the counter to 0 whenever you hit this button.
but it was too late for us.